Ellarigu namaskara. Good afternoon, everyone. If my audio is audible, if my voice is audible for everyone, please reply with Y or yes in the comment box. Or can you hear me? Yes. Thank you so much. ಇವತ್ತಿನ ಈ ದಿನ VLSI ಕರ್ನಾಟಕ VLSI ಇಂಡಸ್ಟ್ರಿ ಬಗ್ಗೆ ತಿಳ್ಕೊಳ್ಳಕ್ಕೆ ನಾವೆಲ್ಲರೂ ಇಲ್ಲಿ ಸೇರಿದ್ವಿ. This opportunity, everyone, we want to become successful in life, but it would be very easy for us if we follow successful people, if we learn from their mistakes, if we learn from their experiences. So now it's an opportunity for everyone to learn from industry experts. So ಇವತ್ತಿನ ಸೆಷನ್ ಅಲ್ಲಿ ನಾವೆಲ್ಲ ಏನು ಜಾಯಿನ್ ಆಗಿದೀವಿ, ಇಂಡಸ್ಟ್ರಿ ಇಂದ ಕಲಿಯೋಕ್ಕೆ ನಮ್ಗೆ ತುಂಬಾ ಸಾಕಷ್ಟು ಇನ್ಫಾರ್ಮೇಶನ್. ಸೆಮಿಕಂಡಕ್ಟರ್ ಇಂಡಸ್ಟ್ರಿ ಅಂದ್ರೆ ಏನು, ಸೆಮಿಕಂಡಕ್ಟರ್ ಇಂಡಸ್ಟ್ರಿ ಫ್ಯೂಚರ್ ಯಾವ ತರ ಇರುತ್ತೆ, ಸೆಮಿಕಂಡಕ್ಟರ್ ಇಂಡಸ್ಟ್ರಿ VLSI ಇಂಡಸ್ಟ್ರಿನಲ್ಲಿ ನಾನ್ ಯಾವ ತರ ಕೆರಿಯರ್ ನ ಬಿಲ್ಡ್ ಮಾಡ್ಕೋಬಹುದು ಅನ್ನೋದನ್ನ ಪ್ರತಿಯೊಂದು ವಿಷಯ ನಾವು ತಿಳ್ಕೊಳ್ಳೋಕೆ ಇಟ್ ಈಸ್ ಅ ಫ್ಯಾಂಟಾಸ್ಟಿಕ್ ಆಪರ್ಚುನಿಟಿ ಫಾರ್ ಅಸ್. ಇಲ್ಲಿ ನನಗೆ ನಿಮ್ ಕಡೆಯಿಂದ ಇಲ್ಲಿ ಎಷ್ಟು ಜನ VLSI ಇಂಡಸ್ಟ್ರಿನಲ್ಲಿ ಸರ್ ನಾನು VLSI ಇಂಡಸ್ಟ್ರಿನಲ್ಲೇ ನನ್ನ ಕೆರಿಯರ್ ಮಾಡ್ಕೋಬೇಕು, ನಾನು ಸೆಮಿಕಂಡಕ್ಟರ್ ಇಂಡಸ್ಟ್ರಿ ESDM ಇಂಡಸ್ಟ್ರಿನಲ್ಲಿ ನಾನು ನನ್ನ ಕೆರಿಯರ್ ನ ಮಾಡ್ಕೋಬೇಕು ಅಂತ ಇದ್ದೀರಾ? ಎಲ್ಲಾರನು ಎಸ್ ಐ ಆಮ್ ಅಂತ ರಿಪ್ಲೈ ಮಾಡಿ ಚಾಟ್ ಬಾಕ್ಸ್. ಹೌ ಮೆನಿ ಆಫ್ ಯು ಆರ್ ಇಂಟ್ರೆಸ್ಟೆಡ್ ಟು ಪರ್ಸ್ಯೂ ದೇರ್ ಕೆರಿಯರ್ in VLSI or semiconductor industry? Yes, I am. Very nice. Priyanka says yes. Savitri says yes. Very nice. So now, very good, very good. So very nice from okay, nice. So now it's the time to invite that person who has an experience of more than 3 decades working in IT industry and in semiconductor industry, whose experience and expertise will be a lot more useful for all of us present here in the webinar. Let me invite Mr. Sunil Acharya, who is Senior Consultant in Karnataka Digital Economy Mission, KEDM. KEDM is a Government of Karnataka initiative. I welcome Sunil Ji Acharya. Welcome you, sir. So over to you.
Good afternoon, everybody, and it gives me great pleasure to be a moderator for this session. We have got a bunch of really expert folks, professionals from the industry who are going to help us, help talk to us about the VLSI program itself that Karnataka Digital Economy Mission is rolling out. We have got some really experienced folks. I will start with introducing some of them. Firstly, I would like to introduce Mr. Gaurav Jalan, who is Senior Director at Marvel Semiconductor. Currently, he is working on the Custom and Compute Solution Business Unit, and he leads a team covering what is called RTL, design verification, DFT, and emulation aspects of the product development from India for Marvel. Gaurav also happens to be an experienced startup entrepreneur, and he would provide us with a great set of insights about the VLSI program and his perspectives on why this program is useful for folks who are interested in getting into the VLSI career space. So welcome, Gaurav. Thanks for being here today. Next, I would like to also introduce Professor Madhav Rao from IIIT Bangalore, one of the key folks who was responsible in designing the program itself. Professor Madhav has received his PhD in electrical engineering from University of Alabama, Master of Science in Microelectronics from Arkansas, and he's a electronics and telecommunications engineer from the University of Mumbai. He currently leads the HIDES and SAL labs at IIIT Bangalore, and he's a key pillar for conducting this course. So we will hear from him as we go forward. We also have Mr. K. Sridhar, who is the CEO of the Semiconductor Fabless Accelerator Lab. So we will hear from Sridhar around the focus on what is fabless and also his perspective on the importance of this KVLSI program that KDEM is rolling out. Sridhar also is a highly experienced and accomplished leader from the semiconductor industry, more than 3.5 decades. And he has worked for several companies, including Marvell. He's been the managing director for Marvell in India. He set up Marvell, National Semiconductor. He's held positions, various leadership positions. He's also been the managing director for RICO in India. Apart from that, Sridhar is also a technologist who has worked in the display space and also is involved in several startups, including the ones in Safal. So we have got a diverse set of people. And we are also hoping to be joined by Mr. K. Krishnamurthy, who is currently the CEO and president of the India Electronics and Semiconductor Association. He has been chief technology and strategy advisor to several startups, also corporate vice president at Rambus and also at National Semiconductor. And he's a veteran from the industry. He has been with Bharat Electronics for more than 20 plus years prior to his corporate career. So we have a whole set of people who have a lot of experience in this space. I would like, maybe Gaurav tell the audience a few things about Marvell, just so that they get the context of where you're coming from.
Thanks. Hello, everyone. I'm Gaurav Jalan.
You're on mute, Gaurav.
Am I audible? Okay, thanks. Thank you, Sunil. Hello, everyone. I'm Gaurav Jalan. I am representing Marvell. So Marvell is a semiconductor company. We develop and deliver semiconductor solutions that move, store, process, and secure the world's data faster and more reliably than anyone else. Now, how do we do that? We are involved in defining solutions for carrier infrastructure like 5G. We are doing enterprise network. We are doing data centers, and we are involved in automotive. Marvell as a company is 28 years old, close to around 7,000 employees worldwide, with 1,500 or so in India. In India, we are in Bangalore, Hyderabad, Pune, and Chennai. It's close to a $6 billion revenue company and holds close to around 10,000 plus patents. So I'm excited to be here. Look forward to the interaction.
Yeah, thank you, Gaurav. We are really excited to have you here to speak to the audience, because they get a first-hand view on from an existing semiconductor company what you're looking for from a career standpoint or job perspective. Over to Professor Madhav Rao. Professor Madhav, can you tell us a little bit about IIITB itself and how you conceived this course, just so that the audience understands the background?
Yeah, thank you, Sunil. Hope I'm audible enough.
Yes.
Yeah, so Ellarigu Namaskara. For all the participants who has joined today, I think it's wonderful to have all of you. So I come from an academic background, unlike others who are in this particular panel. IIIT Bangalore is one of the topmost institute in the nation, and we have a very strong VLSI program. We have a very strong MTech program as well as an undergraduate program in the area of VLSI. And we believe that IIITB, participating in this Karnataka VLSI program, I think more than IIITB, I think the Karnataka as such will be benefited a lot with with training a large manpower in this particular VLSI domain, which indeed I think everyone is looking at in this particular space, especially for our country. We require that kind of a space. And coming from IIITB Bangalore, I think we are one of the prestigious institutes or the universities in India. We have a very great ranking. NIRF ranking is around 70. We have recently received one of the best awards, technical engineering awards. So happy to represent IIITB from my side. So on behalf of IIITB, we welcome all the attendees. Yeah, thank you, Sunil. Over to you.
Yeah, thank you, Professor Madhav. I think the audience will recognize that, IIIT being a premier institution and getting involved in rolling out the VLSI program. Also, like you mentioned, there's a huge requirement in terms of skilled manpower in this space. And organizations like IIITB and KDM, and of course, the industry who is being represented here, will play a critical role in ensuring that we build that highly capable, skilled career. Now, just to switch over to Mr. K. Sridhar. Sridhar, can you tell us something about what SAFAL does and why you think this is an important, initiative from KDM? You're on mute, Sridhar.
So sorry. Okay, thanks. Okay. Thank you, everybody. Thanks, Sunil. It gives me immense pleasure to be on this panel, especially talking about semiconductors, which is a hot topic in the whole country, and representing Semiconductor Fabless Accelerator Lab, which is in short forms called as SAFAL. Most predominantly, everybody is referring as SAFAL. It's an initiative from Department of Electronics, ITBT, Ministry of Karnataka, and also developing industry representations from the whole side of it into it. We're specifically focused at semiconductor and system design ecosystem in India, specifically in Karnataka. We can talk about, as Sunil said, as we progress into it, what is fabless, what is the differentiation between the whole process of semiconductor preparation, and why is it called fabless and fab into it. So as we progress, we will learn more. It's a challenging field and it's a very interesting. A lot of things can be done. At SAFAL, we support all the startups, give access to all the entrepreneurs who are ready to start their new ideas, create something specifically in the VLSI space of it. So for that, educating in that space and creating a workforce for the VLSI side gives me pleasure for doing that into it. As we progress, we will have more interaction. Thanks, Sunil. Back to you.
Thank you, Sridhar. I think you basically hit upon one important point. Essentially, that when we talk about VLSI skills, it is not only for folks who are looking for jobs, it's also for people who want to become entrepreneurs and get into this space of VLSI, creating new kinds of innovation, designing chips or designing systems even. I think this is an opportunity. This will be a foundation stone for people who want to get into the VLSI space. I also noticed some of the audience has started posting a few questions. Please do continue to post the questions, but we will need to affix your email ID so we know in case we are not able to have time to answer those questions in this particular forum, we can get back to you with some of the answers over email. So we will take the questions at the end of the session. We may have about 7 to 10 minutes based on the time available. But I would encourage you to continue putting it in the chat box. Please post your questions, but along with your email ID, so we can clearly respond to it later. So I think we have an interesting panel today. We also have the context as to why this discussion is happening. So let us first of all try and understand. We're waiting for one more speaker to join, but I think I will pose the first question to Sridhar, yourself, Sridhar, just to understand what is the larger perspective on design? Why are people talking about semiconductor or systems design today? What do you see in terms of the industry? Is why is it that suddenly it has taken center stage that people are looking at the electronics and semiconductor industry? Can you just offer some insights on that, and maybe we can go around with the panel?
Yeah, sure. It's a vast subject, and I'll try to cover up a little bit into it. Okay, it's an interesting subject in terms of the whole perspective of the system level designs into it, especially electronic system design aspects of it. Anything related to chip designs ends up in getting into a system level aspects of it. It is very obvious that if you want to make a product, you need to create a complete system into it. And for that, you need to have the skills from the complete space of it. Specifically, in terms of electronics means, there will be an integrated circuit involved into it, be it a small transistor level or it's a whole multi-processor kind of environments. It needs some kind of connectivity and the system level aspects of it. So from that perspective, it's very interesting. And Karnataka, especially in the current situation, we are leading in terms of the whole ESDM spaces of it. Okay, from that perspective, I think it is a right time. Why means because in the geopolitical nature also is making the help for us into make it happening into it, and then the thrust from all the angles, necessity from the user's perspective as well from the support from the government. From all perspective, it is the right time for us to exceed and then create something innovative products to sustain our ecosystem into it.
Yeah, thank you, Sridhar. I think basically this is a huge opportunity, not just for Karnataka, but also for the country to excel in design. And foundational courses such as the KVLSI program will be very helpful. So thanks for that note. We are also joined by Mr. K. Krishnamurthy. Krishna, if you can turn on your camera if possible. Just to introduce Mr. Krishnamurthy, he is the CEO and President of India Electronics and Semiconductor Association, with more than 4 decades of experience, both locally, domestically, and globally in the hardware and design industry. Prior to this, he has been the corporate vice president and managing director of the India Design Center at Rambus, also a managing director of India Design Center at National Semiconductor. And additionally, he has had more than 2 decades of experience at Bharat Electronics. So from the perspective of public sector perspective. So welcome, Krishna. Thanks for joining. And since you joined, just putting you on the spot, if you can tell us a few things about IESA, about the organization that you're representing. Krishna, are you able to hear us?
Can you hear me?
Yes, I can hear you.
Okay.
Yeah.
And are you able to see me?
Yes.
All right. And I'm also sharing a screen.
Yes, we are able to see it.
You're able to see that?
Yes.
Good. I see that about 200 plus participants are there in this call. So India Electronics and Semiconductor Association is a all India organization which represents almost all the electronics and semiconductor companies in India. We are a vertical focused association. We deal with only electronics and semiconductor, unlike FICCI and Confederation of Indian Industries, CII and all that. They are broad-based in various segments and verticals. IESA focuses only on electronics and semiconductors. So that is the first part. Secondly, we are in existence for the last 17 years. We have about 300 plus members. And the slide that you are seeing now shows the major companies that are in operation in India. They are all our members. And you can see on the left-hand side box, all the design companies and the design software companies, tools companies. And on the right side, what enables the electronics and semiconductor manufacturing. A lot of equipments are required, a lot of strategic alliances and facilities are required, and a lot of people to define products are required, and a lot of consumables. For a chip to come out, you require 200 plus chemicals, metals, minerals, gases before a chip comes out to be used in a product. And to give you a size of the what we are talking about, I'm sure you are familiar with this gadget, right? This is a remote control, TV remote control. All of us use it morning till night. This has 7 semiconductor products, semiconductor chips in it. Now, the next one that we don't generally put down is this product. This is our smartphone. This has about 40 of them. Now, just imagine every other product that you touch with your hand as somewhere in between. A laptop that I'm using, that has about 50 plus chips of different sizes, different capabilities, different functions that it does, right? Now, with every revision of the product, you buy a new phone, the features are added, the semiconductors inside them, 50% of them undergo a revision, change to add the new features. Same thing with a laptop, same thing with your 4K TV or any other equipment that you buy, even the refrigerators and washing machines in your house, come up with next generation product, a new chip has to go in. So the opportunity that Sridhar talked about is coming from the demand. Now I will go to the next foil to show you what is the demand that we are talking about. $300 billion worth of electronics will be consumed in India. So when you buy a phone, when you buy a new laptop, when you buy a new TV in the house, the electronics in that adds up to $300 billion by 2026. Conservative estimate, but even if it is, let us say 250 billion, we are talking about the second largest import in the country after oil. Remember that, number one. And number two, out of that $300 billion, the semiconductor component value is $110 billion. Today, in 2021 or 2023, it is approximately 40 billion. 25, it is going to be 64. By 2030, it is going to be $110 billion. So that many new products need to be created. Globally, the semiconductor market is $550 billion. And it is by 2030, it will be $1 trillion, that is 1,000 billion, out of which 110 billion will be consumed in India, which is 10% of the global demand of semiconductors will be in India. Now, I don't think there can be a better opportunity for electronics engineers not to be part of an ecosystem which is growing at a rate of 22% per year. So that is a simple justification. You are assured, you become an expert, you become a good chip designer, you are assured of your future. That's all what I will say. Thank you.
Thank you, Krishna. I think basically you gave the requirement, the demand part, which is basic, that not only domestically, but even globally, there is a need for new products and there's an opportunity for people to get into this business. Naturally, because there is a need for more innovation, there will be both jobs and entrepreneurship opportunities in this space. Just a follow-up question to you, since you set the stage in terms of the global demand, where do you see this intersection between the design requirement, that is VLSI course? Why do you think it is necessary today? Specifically, I think adding on to what Sridhar said, one, of course, the need for new kinds of products, but also the reality is that we perhaps have less number of people who are skilled in this space than what the demand is. Can you throw some light on why this new focus on design? Why are we all talking about semiconductors today? In the last at least year or so, we are hearing a lot, supply chain issues and design of semiconductors. Can you just, based on your perspective, overall across the industry, why is design becoming so important now?
This is to me or?
Yes, this is to Krishna, to you.
Okay, thank you. So why is design important? Design of chips started in India in real earnest in 1995, though Texas Instruments started their first design center in 1985. The first 10 years or so, approximately 10 years, they were doing EDA software development, but 94, 95 is when they started designing chips in India. So for the last almost 30 years, India has been designing chips from the catering to the global chip companies, like the Intels of the world, the Qualcomms of the world. They were all designing chips out of India. Now, during COVID, we found how one small disruption of the supply chain can affect the entire ecosystem of chip availability. And I'm not exaggerating a wee bit. The first time I got a call from Government of India talking about the disruption of semiconductor supply is not from the Electronics Ministry, not from the Industries Ministry, it came from the Finance Ministry. And they were asking what is causing the disruption? When will it end? What is India doing? What is the electronics companies in India doing? Because, and then I asked the question, why is Finance Ministry asking this question? And they said, one truck that is standing out there in the yard, but not getting shipped because you are not supplied one starter chip or ignition chip, is causing a revenue loss of 1.8 lakhs in GST revenue to the government. So there's a huge economic impact in the first place. Understand that. Because when you talk about 7% growth in GDP, electronics today contributes about 4% of that. But developed countries contribute about 10% of their GDP is contributed by electronics and semiconductors. So for us to sustain the growth, number one, to India to sustain growth economically, you becoming a semiconductor major powerhouse is very, very important. Secondly, this $110 billion worth of consumption cannot be supported forever. If you are going to import $100 billion every year, as I said earlier, it is the second largest importer after oil. It is not sustainable for long. So it's absolutely important that Indian entrepreneurs, Indian startups, Indian industry comes up with what is required for the next generation products. I don't see any reason why we need to import a wall plug charger from China for our smartphone. We can definitely build the chip here. We know how to build the circuit for a charger. We know how to get 95+% efficiency, and we can build that product without any problem. We can build the chips for the next generation smartwatches, wearables, IoT products. India has the capability. It has proven global companies are leveraging our talent. And why the design demand is so high? I don't know the latest number, but when I looked at it maybe 3-4 months back, Bangalore alone, there were something like 4,000 plus jobs available in semiconductor design. People were not available. Qualified people were not available, right? So this trend is not going to go away. It is going to stay with us. So that's also the reason. One is the economic factor. Secondly, the demand going to drive new and new innovative products. And third, of course, the global demand. I mean, again, you can very easily relate to, I'm sure all of you are in their early 20s, and what happened to the software demand during Y2K time. People who had any knowledge of software were pulled into it globally because there was no talent available at that time to cater to the software requirements. And we are getting into a similar situation in the next 5 to 7 years for semiconductors. So that is the compelling argument. Thank you.
Thank you, Krishna. I think basically, absolutely agree with you. There is both an economic demand. It makes sense for us to become more self-reliant, but also create products for the world. I think so. Design plays a key role. Thank you so much for that. I will just shift over to Professor Madhav Rao. I think not just from an academic perspective, do you see a new focus on design now, since you are involved on a day-to-day basis from an academic perspective, not just for attending courses, but are you seeing opportunities for research and development also in that space? And again, having foundational knowledge of VLSI and design skills will help both. Actually, I would say in 3 areas. One would be, of course, to find career opportunities. Second is, of course, to look at entrepreneurship opportunities. And third, of course, is research and development. So what is your perspective on this?
Yeah, Hope, are you able to hear me, Sunil?
Yes.
Yeah, wonderful. I think it's a wonderful question, Sunil. So the answer to this particular question is, I feel it's and it's a right time for the VLSI folks, or rather to the freshers or the the electronics interested students to enter into the VLSI domain. And I say this because over the years I've seen what VLSI industry has stood for. This is the right time because I think there is an amalgamation of the AI/ML, which is driving the underlying hardware. I think underlying hardware has to be very, very efficient in terms of performance, in terms of power footprint on the silicon. So it has to be really, really small, but it has to be extremely power and performance efficient. And so what has happened is, although the AI/ML algorithms has given a large amount of space in the application side, in the application domain side, in the Android app side, but ultimately it is what the hardware that really matters. How much chunks of computation one can do. Whether we can do an in-memory computing, whether we can bring the memory, place the memory in, or the computing in between the memory cores. I mean, there are a lot of questions, and that's why it's a very interesting period. It's an interesting era for the students, especially the students of today's world. I think it's a very interesting period because they can not only go to the industry, but they can also pursue their career in the research. So at IIITB, I think we are kind of very, very fortunate that we are very closely working with the state government and as well as with the central government to embark on some of the new potentials of the computations, new potentials of the VLSI design itself. So in that perspective, I think I feel that both one the student who is making career in the VLSI domain, can seamlessly migrate into the research domain, and then the research can seamlessly migrate into the teaching effects. And that was not possible earlier, I feel, and I feel that this is this particular era 2023 onwards, with a strong semiconductor push, with a strong support from IESA, Mr. Krishnamurthy, and with the support from KDM, and also the state government. I think it is the right time for our Karnataka-based students to to ride on this particular wave and become one of the very potential designers for the VLSI. As such, and VLSI as such, I think my feeling is over the years, even the international audience have understood that Indian designers are really good. They are very well recognized. So it's time, for us to do a make in India, made in India, as well as it helps our own entrepreneurs and startups to come up with some very innovative design.
Yep. Yep. Thank you for that. I think basically there is a question. There are several questions saying, why now? What is so different? I think you answered all of them. I think on the three vectors, I think Mr. Krishnamurthy and Mr. Sridhar covered the need, the demand part, the opportunity part. Today it is not just about finding a job. There's an opportunity in research. There is an opportunity in becoming an entrepreneur. We have several entrepreneurs in Safal, which we will talk about later with Mr. Sridhar. Now, let me ask a question to Gaurav, who is from the industry now, right? He's been patiently waiting and listening to us. Gaurav, since you are from the design verification background, part of this course that is getting rolled out, you're part of that background. You also manage a huge team of 350 plus people. You also hire people. So can you tell us or give us a quick overview about this domain? What is this design verification? What is the kind of job opportunities there? And why is it different today? Because there are a lot of questions which are coming up, which are saying, look, I am a VLSI engineer, but I didn't find a job. We have that in several people are asking that question. So I will throw that question to you as to why the situation now is different. What is this DV and why do you need, people have foundational skills, but how do courses like this help them actually become more industry ready? Can you please throw some light on that?
Sure. Thanks, Sunil. Yeah, I'll since our audience is primary students and aspirants, I'll probably talk at a very ground level to start with as to what is design verification. So I'll take an analogy that imagine that you have a guest coming for dinner and you are cooking something. If the guest is important, after cooking, you would want to taste and ensure that it is good. If the guest is very important, you may ask someone else in the house to also taste it for you and confirm that, yes, it is indeed good and you are not running a bias. And of course, the final validation comes from the guest itself. So that the act of ensuring that what you wanted to cook and how the dish turned out, the testing part of it is really verification or validation. When we do the same thing with our designs in semiconductors, we call it design verification. So the way it really happens is like to cook, you will pick a recipe. Similarly, our designers, they'll pick an architecture which is derived from the demand that our sales team would see. That architecture is picked and a designer will start developing a code to realize this design for hardware. Typically, this is done in hardware description languages like Verilog, VHDL, sometimes high-level languages. And then they have to test it. Now, the testing can be done in the same language, usually done by the same designers to start with. As I said, if you are cooking, you will first taste it yourself. But then there is an element of bias, and hence you need another pair of eyes to confirm that your design is indeed accurate. And that is where the role of verification engineer comes into picture. Now, what a verification engineer really does is try to take the design and test it. And to test it, they will develop an infrastructure, they will develop test cases. Basically, they will try to hammer the design in all different ways to ensure that it is a correct and exact representation of the architecture or the requirements document. Now, there are again different languages that have evolved for verification, folks. System Verilog is a de facto standard now. It's an IEEE standard. Similarly, there is to develop the infrastructure, there is a specific methodology. Again, an extended IEEE standard, we call it Universal Verification Methodology. So a combination of this language and the methodology helps you prepare an environment where you can hammer the design. Now, it is not just limited to this, but a basic acumen of smelling out the bugs where they are sitting in the design is the real technique you need to learn. Learning a language and methodology is a part of it, but the real experience comes when you based on your experience, you start finding bugs early, you can debug faster, and then you help to close the design and sign off on it so that it can be realized on a silicon. There are many different techniques, but mostly the industry uses System Verilog UVM-based constrained random verification techniques. Many of the institutes have started teaching them in the graduation or post-graduation courses. There are many finishing schools that are doing it. But what we observe in general is that there is a lot of emphasis on theory and a very limited emphasis on practical knowledge. That is where this program that is launched by KDM primarily focuses on. It brings everyone. You see Professor Madhav, you see myself, you see the experienced folks like Krishna and Sridhar, Sunil. Everyone is putting in their heads together to come up with a scheme that will make the students who avail this facility to be industry ready. There will be enough mentoring, there will be enough coaching, enough guidance to ensure, number one, we fill the gap that Krishna talked about in terms of why now and what is the demand we observe. And secondly, as a lot of questions come in that I have learned it, but I don't have a job. So all these aspects will certainly be covered. And we all are looking forward to mentor you, coach you in the direction to be industry ready and eventually land up on a job and contribute to the initiative, like others said, the Make in India, Made in India initiative.
Thank you, Gaurav. I think you answered both the questions. One is basically why the course is different. Of course, talking about DV was one part, but you were also clear on why you think this, sometimes there is a gap between people having VLSI skills and actually finding, finding a job. And also Professor Madhav kind of reiterated that, there are three paths here. One is the job itself. The second, of course, is to be an entrepreneur. And third is to do some research and development. All three options, one is the timing is right, with all the background Krishna and Sridhar gave in terms of the ecosystem, the demand. Second is the fact that the right kind of course which enables people to be industry ready with practical skills, that is also important. And the third and very important part is to have industry mentors who can actually help students travel through this journey of either choosing any path that they want, whether it is entrepreneurship or getting a career in VLSI or even research and development. I think it is almost like the stars have aligned, the timing is right, and we have the right kind of people and the right kind of courses which are available. So whatever the history, I think the point is that this course has been designed keeping in mind employability, keeping in mind entrepreneurship, keeping in mind research. And that is why it is different, because I see some of the folks have sent a message saying, we studied VLSI on Udemy. I mean, that is different, did VLSI on Coursera, there were a few messages. But again, I think the point that Gaurav is saying is it has to be practical, it has to be relevant to the industry. And that is when you will see some progress. And I think the timing is right. So thank you so much for that input. And then quickly switch to Sridhar, who is from the Semiconductor Fabless Accelerator Lab. I think there are a lot of key terms, Sridhar, like fabless, then you have MSI, LSI. Can you tell us something about what is this fabless and what is the difference between fabless and design? Are they the same thing? Can you just tell us something about some of these industry terms that are used?
Yeah. Thanks, Sunil. I think probably everybody would have heard in the semiconductor space, there's a fab coming up. Okay, what is a fab? Okay, I mean, how is it different and what are the things? For that, I think let's step back and look at it. What is in VLSI per se? I'm sure everybody would have seen into it. A very large scale integrations is the definitions of it. Is the current integration levels at which the transistors are getting integrated into it. And it started off with the small scale integrations, SSI in early 60s, where I think Krishna was also talking about initially how it started into it. And then it went into medium scales in the late 60s. And then it became LSI, large scale integrations in around 70s. And 80s onwards, it's been very large. I mean, where we talk about thousands of millions of transistor getting integrated into it. So from that perspective, it's a different terminologies into it, should be knowing into it. And how we can, I mean, for example, what is a fabless and what is a fab? Fab is a fabrication, it's a short forms into it. And the process wise, if you put the whole thing, first comes the design phases of it, and then the manufacturing or the fab portions of it. In the design itself, like Gaurav talked about small portions in the whole process of verification, design verifications into it. If you put the whole space of design phase itself, the ideations is the first phase into it. You have an idea, you have some specification of a device or a system level into it. Then you get into the design of those things, RTL, coding, or some of the things. Like Gaurav was also saying that we can do it in Verilog. It was some of them are VHDL. Some of those spaces comes into coding of the whole spaces of it. And then the functional verification. We talked about, I mean, the chef himself testing a little bit and then into it. That's the functional verifications into it. Then once you have this, then you get into synthesis levels and then get into the physical design. Physical design by itself has plenty of scope in the each spaces of it, synthesis, floor planning, placement, clock insertion. It's a very vast area which needs to be covered from the design perspective itself. After that, I mean, we talk about once you have the design, and DFT is one of the things, design for manufacturability. Once you have the device, how to test it in a mass is a different aspects of it. So then you get into the tape out, then it gets into the fabrications mode. Once the fabrication is done, you get back to post-silicon validation. So each area is very, very vast, and it needs some fundamentals to be very strong into it. I think the course which has been designed from VLSI gets into some of these spaces and then talk about the design aspects of it. So it's very, very critical from that perspective. So fabless deals with before getting into the manufacturing of it. So there are a lot of options into it. Krishna talked about very early stages of what we did it. In the sense, India was very, very active in preparing many of those I mean, Qualcomm's or you talk about NVIDIA, there are a lot of design centers which were present. All the designs were done here. Fabrications was done in Taiwan. So some of these spaces, we were having a lot of interactions with those things. So there's an edge for us naturally, which is coming up. So we should be able to utilize that at the right time and the whole spaces of it. And all of them requires fundamentals to be very strong into it. And that's where I think, including the spaces of design verification, there are fundamentals, clock insertion, there's a huge subject, and we need to be very clear into it. So that's exactly what I think this course will try to address to some extent into.
Yeah. Thank you, Sridhar. I think you brought a very important point, because sometimes when people think about VLSI, they think of it as a very narrow area, but I think just to highlight, there's ample opportunity. There's a diverse set of specializations that students can get into once they have the foundations in place, physical design, design verification, RTL, there are so many areas where you could do research, you can differentiate if you're starting a company, or if you're taking up a job or a career, you can specialize. I think the idea behind this course is to provide those foundational elements which will help you be industry ready. Obviously, when we say industry ready, every company will have its own specific requirements, but the idea here is to provide the foundational elements. So on that note, I will just switch to Professor Madhav. If you could quickly describe how this course is structured and what are the key elements of this course for the potential interested attendees.
Right. I think it's a right time to talk about the course, the curriculum of the KVLSI. It's a 9 months program where we have segmented into 3 parts. The first 2 months will be a rigorous theory, which will cover digital CMOS part of the course, which will also cover some aspects of analog CMOS, analog VLSI design. And it will also have the system Verilog component. And an embedded system component, just to understand, just to get a feel of the system, so that in the future, if the students are interested in developing a system on chip, I think this particular embedded systems course will be a very critical component. And then we have 2 additional courses, which is of kind of very close to the industry standards, is the high level, the synthesis course, and the formal verification course. I think both these courses in somewhere is kind of helps the students to seamlessly do the transition to the 4 months of the lab course. So the 4 months of the lab course will be done, of course, outside the IIITB campus. But the first 2 months will be inside the IIITB campus. The next 4 months will be done by our lab partner. We have selected a very a nice lab partner. A very rigorous curriculum is put on the lab side. After the 4 months, I think the last 3 months of the particular curriculum will be spent in the industry as a part of the internship. And this is where I think IESA will help us in identifying the right set of the industry partners. So overall, if you look into this particular curriculum, it starts with a very short 2 months of rigorous, I would say around 75 to 80 hours of theory in the 8 weeks of span. 9th week will be an exam, just to validate how well we have taught and how well the students have understood. And then 4 months of the lab, and the lab will be heavily focused on the verification. That is where the industry jobs are oriented, but also there will be other aspects of the physical design and the backend design as well. And then I think switching into the 3 months of the internship. All right, so the students interested in this particular program are likely to, they have to shift to Bangalore. They have to find their own place to stay, and come to the IIITB Bangalore campus, 5 days a week for 8 weeks or possibly 9th week, and then move to the lab partner space. So they have to formally shift to Bangalore. All right, so that's it from my side. Hope that answers Sunil's question.
Yeah, thank you, Professor Madhav. For the attendees, all the details will be made available as part of the poster. But I think the key part here is, there were questions which are asking, why is it different? Or the key part, I think Professor Madhav clearly articulated is, this is an intensive, serious course. It is not a Udemy online course where you can go and study something theoretical. This will involve being actually involved in hands-on training, lab training, and also partly an internship part. So therefore, also the number of seats available is also limited. So the idea here is to provide intensive training to make people ready for the industry, as much industry ready as possible. So any additional questions, please continue to post. Now we will quickly move to the Q&A session, and I'll open it up to all the panels. Challenging questions are coming in from the attendees, so I think it will be interesting for the experienced folks. So I will leave it to, I think you can take turns to answer it. The most important questions or repeated question that is coming is, I have been trained on VLSI for the past 2 years. I saw a huge recession in November. There are 2 sets of questions. One is the experienced folks who are seeing a recession in spite of being trained in VLSI. The question is, why do you believe that there will be more jobs now in the forthcoming years? The second question is, freshers who are just graduating with some VLSI knowledge because of their foundational engineering course. they are asking questions on, okay, how can I, as a fresher, what should I do to find a job? So one is experienced folks who are feeling that, where is the market? You are talking about 4K plus jobs. Where are they? I don't see them. The second one is, I'm a fresh engineer who has some basic VLSI skills. What should I do to find a job or entrepreneurship? So Professor Madhav, since you're online, I will start with you first. You can take that and then we can pass it along to the panel, and each of you could add your own perspectives on that.
Yeah. I think I'll definitely take help from Krishna sir, who understands the market really well. But from my perspective, I feel there are jobs for the students who have understood the subject and who has gone through the rigor of the curriculum. There will always be the jobs. So I think this particular KVLSI program or the curriculum is one such curriculum where the intention is to have a very good understanding of the theory, do the lab component, verify the lab component again, backtracking the lab component with that of the theory components, whether it makes sense to whatever design we have done and whatever the simulation results we have got, whether it makes sense in whatever we have learned in the theory, and then seamlessly do the transition into the 3 months of industry. And I think if the students are able to follow this particular 3 segments of the VLSI cycle, I think I'm pretty sure that they will be in a much better position to be hired by the VLSI industry experts. Generally, I think if you see most of the components, either in a VLSI setup, I think you will see that the VLSI school is generally set up for theory, or they are set up only for the certification programs, or for the industry. But this is a very unique program where all the 3 segments are coming together, and it is a very oiled or well-laid pipeline. And we have been thinking about this. I don't know, Krishna sir started this 2 years back, I think, thinking about this, and that is his kind of a brainchild. And we have been planning this for the past 2 years and have come up with this particular pipeline to make sure that the students are ready for the industry.
Thank you, Professor Madhav. And then we'll hand that over to Krishna, since you referred to some of the concepts that were there and the flow. And so, Krishna, do you want to add to that point around?
Sure. There are 3 different sub-questions I would like to address. Number 1, how is this course different? Because I saw some people have said, I have attended that course, this course, and I didn't get much knowledge out of it. So the fundamental difference is the value that IIITB is bringing to this program. So when I had the first discussion with IIITB, the emphasis was to get the fundamentals very strongly moved. So about 70-75 hours of theory class has been designed, which is not available to you in any other finishing schools, programs like they teach 4 or 5 months of verification or physical design. You don't get into the fundamentals first. So if you want to become a good, successful engineer who is not impacted by the cycles of ups and downs in the industry, your fundamentals have to be pretty strong. And I have spent 22 years in this industry before I started managing IESA. So I can say with great amount of confidence that if your fundamentals are good, you're going to be always in demand, number 1. So this has got theory first, then a very good finishing school is going to teach you the labs. And again, it is not that what they select, the industry is going to work with them to make sure that they teach what is relevant to the industry. And thirdly, it also has the element of internship. So you're going to be working in an industry, in one of the design companies, design houses, and you'll be actually doing live projects. So these 3 combination is what's going to make this course extremely valuable. I saw another question asking whether this course is free. It has been highly subsidized, and I can assure you that what you will be paying is probably what you will spend on your birthday party and what you will spend for buying the next phone combined will pay for your fees. It's not going to be anything more than that. And that's going to give you a career which gives you a starting salary in excess of maybe 75,000-80,000 per month. The current fresher salaries of the range of 8 lakhs, 9 lakhs kind of thing. So purely from a business point of view, if you look at it, the amount of money you invest versus what you get as return in terms of quality of education. And that's why, I mean, maybe you got confused by the name KVLSI, we will brand it better. But this is not just one of those VLSI training that is out there in the market. This has been highly customized, highly curated by the industry, and the mentoring during the internship is going to be done by the industry itself. So this is the second part of the questions, that a summary of the questions that I saw. Third, is this meant for freshers? Yes, absolutely. If you have just completed your graduation, do this for 9 months. It is like a very good elective subject which you study deep, and then you become ready for the industry. And our guests now, from the industry point of view, we all believe that if you come out successfully, all the phases of testing and all the phases of assessment and all that, most probably, I would say a very, very high chance that the company where you are doing internship will hire you straight away, because you have come through very good training, skills in the labs, fundamental training, and an industry internship. We don't see any reason why the internship company will not hire you directly. So these are the three aspects I would like to highlight. Thank you.
Thank you, Krishna. I think you comprehensively covered most of the questions that were there. I'll just, for last closing comments, since we have 5 more minutes, I will go to Gaurav. Gaurav, you're basically a hiring manager. Let's look at it. I'm not asking you to hire everybody, but what is it that you would look for from a VLSI engineer? Let us take design verification, which is your forte and probably your department. What is it that you would look for? One of the key parts, I think Professor Madhav clearly said, the fundamentals have to be clear. Krishna clearly said the whole course has been designed to make sure that people are, grounded in the fundamentals and are industry ready. What would you as a hiring company look for, just so that they understand? Many of them are talking about what is missing, what have I not done. One is, of course, they have not had the hands-on, well-oiled, designed course such as the KVLSI program. What else do you think as a hiring manager you would look for in people who have completed some basic, or let us say foundational VLSI training, even if it is DV, for example?
Sure, Sunil. I think that is the basis for our course definition and design, that fundamentals, as Professor Madhav talked about, is the basis. And then typically what we as hiring managers find is that fundamentals, there are 2 ways to learn fundamentals. One is you just learn the theory and you cram it to an extent that you can spit out whatever is asked and you can call it fundamentals. But the application of fundamentals, right? And that is where the second phase of our program, as we spoke, comes, where a finishing school comes in. There is a lot of back and forth between theory and lab, and those labs also is not going to be plain vanilla. We are trying to come up with a level of challenges that will increase in the lab. So you are not working on designs that you cannot count on. And then, of course, the third aspect is actually you are doing an internship where you see how real projects run, you see how a corporate runs, what is an expectation, and that puts the icing on the cake that holistically you get an experience to make you industry ready. Companies like us, we do hire freshers, and almost in a similar way, we sometimes run our own internal programs with the hired freshers. So we are now opening up that thought process, that philosophy, to help design this program to ensure that it is not focused on only one aspect, but covers everything that is required to be ready for industry and get hired.
Thank you, Gaurav. And Sridhar, any last comments on the course itself?
I would throw like slightly different. I mean, the very fact that it is getting trained from IIT Bangalore gives an opportunity to everybody to think differently. I mean, including the course materials and everything. And each of them, the way it has been structured is to become an entrepreneur by themselves into it, by creating something new, innovative ideas to come through it into it. Of course, everybody talked about fundamentals and the whole prospects of clean executions of all the aspects of it. And if you can think as a full product system level things and then come up with a solution and thought through, with a training program, what coming up, then you will be really doing some innovative products out of it. And government of Karnataka also encourages from, there is an Elevate program which is given to all of us, where we can use it, create new products, apply for the new ideas to come through it, funding wise is supported. So young entrepreneurs have been encouraged to come up with multiple options into it. So from that perspective also, this course will definitely help to think through differently.
Thank you, Sridhar. I think that's a different perspective. Like we mentioned earlier, I think there are opportunities to look at job careers. There are also opportunities, like you rightly said, for entrepreneurs. I think one key part we want to reiterate is, well, like Krishna said, this is for freshers, but this is also for mature professionals who want to look at VLSI as a career, or want to become an entrepreneur, or want to move laterally. So that is also an option. And like Professor Madhav mentioned earlier, we are obviously looking for new research and new opportunities. So for both experienced and freshers, the KVLSI program will definitely benefit at the end of the day. So I think we are right on the hour. And Krishna, are you going to share something? Krishna, you're sharing.
I just wanted to
Sure,
show the
Yeah.
report that has been produced by Government of India. It is there in MeitY's website, Ministry of Electronics website. Please go and read it. That tells you the actual requirement of the talent for semiconductors in India. And it will give you a complete breakdown of what is required. It's a very comprehensive report. IESA was involved in preparing this along with Ministry of Electronics. Please take a look. It is available for downloading the Ministry MeitY website. Thank you.
Thank you, Krishna. And I would like to thank all the panelists today. I think you've shared your inputs, and I'm sure the attendees will benefit from the wisdom and experience of the collective, I would say, huge amount of professional experience in the team that has been on the panel today. We've had a diverse set of inputs. One is from the academia, from an academic perspective. Then we had the entrepreneurial part, then the overall ecosystem itself also, and also from a hiring manager as to what is different about this course. So I would encourage all the attendees who are interested to quickly register for the course. There are very limited seats available because the intent is to make sure that there is a small group for which there is intensive training provided, and that the right kind of outcomes are available to us. So I'd like to thank once again the attendees and KDEM, as well as the panelists, for your inputs to the prospective, I would say, candidates for this course. And I would hand it off back to the organizers to close the discussion today.
Thank you so much. So firstly, I would like to express my gratitude to all the panelists. K. Krishnamurthy, who is CEO and President for IESA, Mr. Kapil Sridhar, who is CEO of Safal. I would like to express our gratitude to Gaurav Jalan, Senior Director Marvel, and Professor Madhav Rao, Associate Professor at IIITB, for sharing their valuable insights and expertise on various topics which help us gain understanding of current trends and challenges. I would like to thank Sunil Ji Acharya for beautifully moderating and to get best out of the webinar. On behalf of Karnataka Digital Economy Mission, I would like to thank all the participants, VTU, Reva University, and all NAIN colleges in helping these students utilize this opportunity. And for all the students and the participants to know more about this course, please visit karnataka.digital.in/K-VLSI. We will also post this in the comment section. To know more about this course and to get these opportunities, you can visit karnataka.digital.in/K-VLSI. Thank you so much, all of you. Before that, we will, if participants can turn on their video, we can take a group selfie in the virtual meeting. So we can, if everyone can turn on their video, and I would also request all the panelists to turn on their video. So we can take a quick snap of this webinar. Okay, thank you. Okay, thank you so much, all of you. Thank you for joining this webinar. Thank you, panelists, and thank you, participants. Thank you so much. All the best.